Good evening, my YouTube viewers. In this video, we're going to be doing an A/B test, and this A/B test is going to be concerning click-through rates of websites. And so the specific question that we're going to ask is, does changing the color or size of the Buy Now button increase the click-through rate on an e-commerce website? And we're going to answer that question by writing a program in Python. And so before we write the program in Python, we have to import some libraries so to execute the program because they're needed. So we're going to import NumPy as NP, which is a numeric library and creates NumPy arrays. We're going to import Pandas as PD, which is a data processing library, and it also creates data frames in series. We're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import chi-square contingency. So scipy is Python's scientific library, and stats is the statistical module within scipy. And chi-square contingency is a function within the stats module. So what we're going to do is we're going to simulate the data for click-through rates for the A/B testing. And before we do that, what we're going to do is we're going to set our seed. And you have to set your seed because in order to make sure that the variables are initialized the same way every time you start the program. So you set the seed by typing np.random.seed and any number you want within the brackets. So the total visitors equals 1,000. And the group A, which is the original button design, which is the control group, is group A visitors equals total visitors floor 2. And then that's floor division, you round down to the nearest integer. And group A clicks equals np.random.binomial brackets group A visitors, comma 0.1. And so that's a 10% click-through rate for group A. So this is just simulated data, but we're using a binomial distribution. And when you have a binomial distribution, it means that you have one of two outputs. So it can be yes and no, 0 and 1, true and false, on or off. That's the purpose of a binomial distribution. And then so now we set up the simulated data for group B, which is the new button design. So group B visitors equals total visitors floor 2. And group B clicks equals np.random.binomial brackets group B visitors, comma 0.15. So that means that the new group B, the new product design, or the new button design, has a 15% click-through rate. So the old button design has a 10% click-through rate, and the new button design has a 15% click-through rate. And so basically this is just simulated data to show you how to run the test. So we're going to create a contingency table for the chi-square test. So data equals np array, brackets group A clicks, comma group A visitors minus group A clicks. So that's click and no click for group A, and then the comma, and then group B clicks, comma group B visitors minus group B clicks. So that's clicks and no clicks for group B. So now we're going to run the chi-square contingency test. Chi-square, comma P, comma underscore equals chi-square contingency data. So that means they're going to be collecting the data on the chi-square test statistic, and the P is the probability or your p-value. So now what we're going to do is we're going to print the results. So you're going to print the group A click-through rate and the group B click-through rate, the chi-square statistic, and the p-value. So the Group A click-through rate is 9.8 when we set it up for 10%. And the Group B click-through rate is 15.4 when we set it up for 15%. So Group A is your control group and Group B is your variation group. Your chi-square statistic is 6.6 and your p-value is 0.10. And so basically what's going to happen is if the p-value is less than 0.05, then the null hypothesis is going to be rejected. So the null hypothesis is there's no significant difference between the click-through rates of the control group and the variant group. And the alternate hypothesis is there is a difference between the click-through rates in the control group and the variation group. So since the p-value is 0.10, you're going to have to reject the null hypothesis, which is there's no significant difference. And then you're going to have to accept the alternate hypothesis. So the alternate hypothesis is that the difference in the click-through rates is statistically significant. But what we'll do is we'll go back to the programming, and you can see it asks the questions if p is less than 0.05, which it is because it's 0.01. The result is the difference in click-through rates is statistically significant. So now what we're going to do is we're going to plot our data onto a chart. So labels equals clicked, comma, did not click. Group A data equals Group A clicks, comma, Group A visitors minus Group A clicks. And Group B data is Group B clicks, comma, Group B visitors minus Group B clicks. X equals NP dot arrange, then labels, and that's going to be 2 because you've got 2 labels, clicked and not clicked. And width is going to be 0.035 is your bar width. So now what we're going to do is we're going to create a bar chart. So plt.figure brackets fig size equals 6, 4, plt.bar brackets x minus width divided by 2, group A data, width, label equals Group A original, color equals blue, alpha equals 0.7. And plt.bar brackets x plus width divided by 2, Group P data, width, label equals Group B new design, color equals orange, alpha equals 0.7. So now we're going to add labels to the graph that we just made. So the title is Click-Through Analysis, Original versus New Button Design. X label is outcome, Y label is number of visitors, X ticks is X, labels. You get a legend. Your grid is axis equals Y, line style equals dashes, alpha equals 0.7. And now what we're going to do is we're going to insert some code to put the numbers on top of the bars. So you've got plt.typeLayout and plt.show. And so you can see that the click-through analysis, original versus new button. So blue is your original or your control group, and orange is your variation. It's the new design. So in the original design, you had 49 clicked and 451 did not click. So that totals a 500. And in the new design, you had 77 clicked and 423 did not click. So you had, I'll say 28. I hope I'm doing my math correctly. But you have 28 more clicks with the new design than the original design. So a data-driven decision would indicate that the management would select the new design over the old design because it got more click-through. It got more clicks. So that concludes this particular video. The next video, we're going to do another A/B test, and I hope you decide to watch it.